the product and the reactants benzene, okay? And for the mass, for the yield basis, you choose mass. And then you can assign the same value as I show here, like the hydrochloric acid, that's 0.001, 0.001. And for the other products, that they are respectively 0.04 and 0.04. Okay? And then basically you can run the result.
How much is the chlorine is 0, right, sir?
Yeah, it's
Oh,
zero. Is there anyone who can obtain a result?
How about the temperature for the specification?
It doesn't matter what's the temperature or pressure you assign because, again, this is a simplified reactors.
Oh, okay. Ini tuh ngomongin yield atau ngomongin? Oh, yield.
Okay, in Aspen, the dichlorobenzene, they have a P dash as para. Okay.
Mas. Itu oh ini input.
Okay. Okay, I'm choosing the property method as okay. Para. That's my preference. Okay, my model is developed. Now I'm developing the reactors model. And reactors choose yield here. And connects the feed and connects to the destination and then assign the feed. Aluminum, the temperature is 6 bar or 100. And then what I assign? Okay, I just arbitrarily define the inlet conditions like temperature of 100 degrees Celsius, pressure is of 6 bar, and there will be 100 kmol per hour, and the mass fraction of such three is respectively 0.3 and 0.7 for the chlorine and the benzene respectively, okay? And then we have to alter, or we have to define our yield reactors here. Okay, again, this is a simplified reactor, so you can later check what's the temperature pressure effect. Okay. What I was just told you is that now you have to assign component yield. Okay. So okay. I see component yield. Okay. Now we can define all the components here, and we basically include all of them. Despite we are going to assign some of them as 0. Okay, 0, 0.001, 0.04. Okay, this is an example I saw from our reference book. Okay, now the block yield, R yield is okay and good to go. Are you okay? And then you can execute the simulation. Again, it shows you warning. And try to read what's the warning for. It shows you that the elements are not in item balance. So the conditions we specify may, okay, it's not adequate. Otherwise, it won't show you such a result. And for your end to this course, if your result is like result with available with warnings, I think that's okay. But if that's error, for sure you are not able to get any result for present. Okay. And that tells you that the yield has been normalized by a factor. Okay. Okay, let's jump into the string result and see what's going on.
Professor, can I see your setup, the R yield setup?
Setup?
Yeah. You have benzene. Oh, benzene is 0. I mean, on the board you have
okay.
Benzene up there, right?
Oh, chlorine. Oh, we still have chlorine.
You have
and
chlorine.
that's. Oh no, that's here. Okay. I was in the very bottom row.
Oh.
But now they're complete.
Oh yeah. Okay.
Yeah. Oh, it's okay. You can choose either or more. Let's switch to wet mass, okay? And then reset. And then control panel and run again. And it shows you the identical warning issues, okay? So it's okay. That's not a critical problem. Let's check the result. So for these examples, we have only just one feed and one product, okay? And here are the temperatures and pressures here. They are basically what you have assigned. And for the products, the condition of temperature and pressure will be identical to the reactors. Okay? That's a 50 degrees Celsius, 3 bars, what I've been assigned for the reactors. Okay, so we have switched the yield as the mass basis, right? So the results of the products, I mean the yield distribution should be identical to what we have been assigned. They are like the chlorine, there is no chlorine, and there is no benzene. But how about the other three products? Because the values you see here, they are 0.012 or 0.493 or 0.493 respectively. So they are not consistent with our define, right? You check your reactors R yield and see the yield distribution definition. That's not consistent with the whiteboard over there. Anyone who can tell me why? Or what's wrong? What's wrong with the result?
Because the result that we get, it's with warning. The atom balance is not balanced, right?
That may be a reason.
Oh.
But how can you verify this idea or verify this idea?
No idea. To check it.
Okay, the question is, in the definition of the yield reactors, we have defined our product distribution like here. Okay, so the definition is not consistent with our result, despite there is no error messages. So my question is, why? What makes the inconsistent?
Oh, we skip the coefficient, is it?
What is coefficient?
The coefficient of the reaction. We have the
Have you
stoichiometry.
defined
The stoichiometry.
There's no stoichiometry.
Yeah, is it?
Yeah, there's no. So
Oh,
the result should not from
stoichiometry.
the coefficient. Anyone?
Is it because from the condition, like the temperature and the pressure that we give it even from the starting point?
That may be possible. You can choose, okay, you can alter the conditions, right? How about you just use your computer to alter the condition from the current temperature pressure, to another one to see the result, and you let me know if your result is if your result remains the same or not now.
Because this is aromatic component, so the reaction is hot, so it cannot get 100% efficiency.
Is there any place that you define the percentage of the reaction for that reactor? If that's the case, how can you control the result? Or how do you know? How can you control the result? I mean, how can you define? Okay, if there is such place for do the definition of the percentage conversion. If you remember our settings, we only define the temperature and pressure, right? And then we jump into the yield distributions, like this one, and we execute the result. Okay? Indeed, the results are consistent. They are consistent, despite the values are different. Because as I mentioned, Aspen Plus, as I mentioned when we do the input setting, okay? When we have an input setting like here, we always keep the total fraction, no matter it's more fraction or more mass fraction, we keep it as unity. And I also mentioned that if that's not unities, if the total mole fraction is, or mass fraction is not unity, Aspen plus will normalize for you. So we said in our last case that if that's the 0.5 and 0.5, the result will be identical to 0.1 and 0.1 because Aspen plus it will normalize for you. Okay, make the total fraction as unit, as 1. If you accept this point, indeed this is how Aspen works. If you accept this point, you can see the yield basis now we assign is not a unity. The total is not, the summation is not 1. So if you divide it 0.001 by the total yield as 0.081, okay, you will get the result of this. That happens to the other species. Okay? So the calculation is correct. And it does not relate to your reaction conditions. You get me, this gentleman?